Hi guys, today we're going to be looking at a question on reaction rates. The reaction of zinc and excess diluted hydrochloric acid is used to investigate factors that affect reaction rate. The balanced equation for the reaction is this. The reaction conditions used and the result obtained for each experiment are summarized in the table below. The same mass of zinc is used in all experiments. The zinc is completely covered in all reactions. The reaction time is the time it takes the reaction to be completed. Question 5.1. Experiment 1 and experiment 5 are compared. Write down the independent variable. As we can see, in experiment 1, these are our values, and experiment 5, these are our values. And the only thing that is different between experiment 1 and experiment 5 is the temperature, as experiment 1 is at 25 degrees, whereas experiment 5 is 35 degrees. This means that the independent variable is temperature. Question 5.2. Define reaction rate. Reaction rate is the change in concentration of the products or the reactants per unit time. Question 5.3. Write down the value of X in experiment 4. In experiment 4, we see it has a concentration of 1.5, which is the same as experiment 2. It has a volume of 400 centimeters cubed of HCl, is granules, has a temperature of 25, and the reaction time being X is what we want to calculate. So all the values except for the volume are the same as reaction 2. However, in the question they say excess dilute hydrochloric acid is used. Therefore, since the hydrochloric acid is already in excess, the volume of the hydrochloric acid does not matter. Therefore, reaction 4 and reaction 2 will both have the same reaction time, being 14 minutes. Question 5.4. The Maxwell-Boltzmann energy distribution curves for particles in each of experiments 1, 3, and 5 are shown below. Identify the graph A or B or C that represent the following. 5.4.1. Experiment 3. Give a reason for your answer. Experiment 3, as we can see, has the highest concentration. Therefore, and it has a volume of 200 centimeters cubed. This means that between reaction 1, 3, and 5, it has the highest number of moles. Therefore, it will be graph B. Question 5.4.2. Experiment 5. Give a reason for your answer. As we can see, in experiment 5, it has the highest temperature, being 35 degrees Celsius, whereas experiment 1 and 3 are at 25 degrees Celsius. This means that experiment 5 would therefore be graph C, as due to the high temperature, more molecules will have a higher kinetic energy. Question 5.5. Experiment 6 is now conducted using a catalyst and the same reaction conditions for experiment 1. Question 5.5.1. What is the function of a catalyst in this experiment? So, the function of a catalyst in this experiment, and in any experiment, is to speed up the reaction. Therefore, it increases the reaction rate. Question 5.5.2. How will the heat of reaction in experiment 6 compare to that in experiment 1? Choose from greater than, equal to, or less than. When a reaction has the presence of a catalyst, it only changes the rate of the reaction. It does not change anything else in the reaction, such as the amount of products made or the concentration of the products at the end of the reaction. Therefore, the heat of the reaction will still be the same as experiment 1, making our answer equal to. Question 5.6. Calculate the average rate of reaction in moles per minute with respect to zinc for experiment 2 if 1.5 grams of zinc is used. So let's go back to the thing and see what are our values for experiment 2. So in experiment 2, we have a concentration of 1.5, we have a volume of 200 centimeters cubed of HCl, and a reaction time of 14 minutes. So our concentration is 1.5, our volume of HCl is equal to 200 centimeters cubed, and our reaction time is equal to 14 minutes. So, in order to solve this, we first need to get the amount of moles of zinc used. So, the moles is equal to the mass of zinc we have, which they say is 1.5 grams, over the molar mass of zinc, which you can get from the periodic table, being 65. We then get 0.023 moles. We then can calculate the rate, which is equal to negative delta N, so the change in moles over the change in time. We then can say the change in moles is we end at 0 and we start at 0.023, and that's all over 14 minutes, which is what we end at, minus 0 because the reaction hasn't started. And when we plug all of that into the calculator, we get 1.65 times 10 to the negative 3 moles per minute as our answer. And that's all for this question. Thank you.